Hello everyone, I'm Alfian and today we are going to solve the Leetcode challenge on the challenge number 832 called the flipping an image. And for this particular challenge, given an n by n binary matrix of image, flip the image horizontally, then invert it and return the resulting image. To flip an image horizontally means that each row of the image is reversed. For example, flipping 1, 1, 0 array horizontally results in 0, 1, 1. To invert an image means that each 0 is replaced by 1 and each 1 is replaced by 0. Just a binary operation. For example, inverting an array elements consisting of 0, 1 and 1 resulting in 1, 0, 0 is because if we happen to convert it by horizontally, then of course the 0, 1, 1 will be 1, 1 and 0. Why? It's because the left one right here will be placed to the right one, and for the right one will be placed to the left one, and the middle part will stay the same. Let's say if we have 0, 1, 1 and then 1 again, or 0, 1, 0, 1. And of course, flipping it horizontally will resulting in 1, 0 and 1, 0. And it's just like reversing an array, but it's reversing a string, but in this case we are reversing an array. Hence, it's called flipping horizontally in other words. So how do we invert this? After we flipping it horizontally, to invert this, of course, we are going to use the 0 since it's already 1 on the first index, and 0 will become 1, and also 1 becomes 0, and for the last one, 0 becomes 1. Let's say if we have 0, 1 and 1, of course it will be 1, 1 and 0, and then we invert it and the result will be 0, 0 and 1. Another example, if we have 0, 1 and 0, flipping it horizontally will still result in 0, 1 and 0. Why? It's because 0 on the left side is the same on the right side. If we happen to flip it horizontally, then it will stay the same. Only the 0 will be placed on the left side, and the left side will be placed on the right side. And if we happen to invert it, then of course we will get 1, 0 and 1. And for this case, the example 1 right here, the image is in the form of 2D array, and that would be tricky to solve. It's because a 2D array right here, or a matrix, will be in the form of, let's copy this to make this easier and more faster. Let's say we have 2D array like this, and it is also the same as like this, and the next one will be like this. Let me align this to see if it resembles a 2D array like a matrix. So it's called n by n binary matrix image, and this is in a form of matrix, and the output is of course 1, 0, 0. It's because 1, 1, 0 will be flipped as 0, 1, 1, and to invert it, 0, 1, 1 is going to be inverted as 1, 0, 0. Remember, 1 becomes 0 and 0 becomes 1. And also for the example number 2, we have n by n 2D array. In this one is, I assume it's 4 by 4 matrix. I can say it's 4 by 4 matrix is because there are 4 elements of the first depth of the array of numbers, and for the second depth there are 4 elements on each of them of the image array. And the constraint, it says n is of course equals to image dot length, and the n right here is image of the I of or the nested array with the length property is equals to the n. So these statements resembles the matrix will always 3 by 3 or 4 by 4 or 5 by 5, and the maximum possible constraints is 20 by 20 length of matrix. and for every element of the matrix is either 0 or 1. So there it's not going to be 2 or another number other than 0 and 1 or any characters. So in order to solve this, we can use, of course we have to return, since it demands the function itself of the flip and invert image function that takes the parameter of image in the form of data type of 2D array of integers, and of course it demands a 2D array of integers. So we can pass in the return statement as the image right here. And for the above the return statements, let's delete this example or the visualization of what we are trying to solve right here. And to iterate this, we can use the for loop in I is equals to 0 as long as I is below the image.length, since it's in the form of array, I is plus plus. Then to make this even more simpler, I will show you another approach called the integer array right here, just 1D array of the image array, and using the colon sign, and we take image passing from the parameter right here. So it is the same as using the traditional for loop, using the in I equals to 0 as long as I is below the image.length and I plus plus. And we are iterating the image array right here in a form of one-dimensional array within the image array. So in other words, the image array right here iteration, we are iterating this image array right here, and then for the next iteration we are iterating this array and also this part of the image array as the last element of this image array or the image 2D array. And so to prove this, we can simply use the system out.println, but I believe that using this system out.println image array will result in a standard output of non-recognizable array, is because we are using the system out.println of the array instead of using a nested iteration to iterate every elements inside of the sub array right here, or the nested array. So to dissect this standard output right here, in order to make this readable, then we can simply use the for integer of the number inside the image array, and inside this for loop we can simply move this by I'm using the alt and holding alt and then up arrow sign. You can do that too on your keyboard. So we can simply pass in the current number of the current image array iteration. So let's run this to see what is happening. And of course we have 110 right here as printed, and then for the next one 101 just like this one, and for the last one is 0 0 and 0 just like this part. Okay, so I hope you get the better idea from this visualization, and let's declare 2 pointers to flip the subarray horizontally or the image array horizontally, or just like we are reversing a string by using integer of the left equals to 0, always starting from 0, and for the right pointer will starting from the end of the subarray right here, and elements. To the right, of course we take the image array dot length, since length will returning the length of the array. Let's say we have length of 3. Of course if we happen to use 3 directly, then we can get out of bound array above this 0. Why? It's because 0, since it's a last element, the array always starting from the index of 0. So for the 1 right here it's index 0, and for the 1 right here it's index 1, and for the 0 right here as the last element it's index number 2. And of course we have to shift it just by 1 by using length subtracted by 1, and then we can get the last element of the right pointer right here. We can use the while loop while the left is still below the right, If it is, then we can simply pass in our temporary, storing the left variable or the first index, preserving the first index, so we can place it on the last index without having the right index overriding the first index on the while loop operation. Temporary, we are storing the image array of the left index, which is 0 right here, and then we override the value, overriding the elements of the first elements of the left pointer right here with the one from the right pointer. For the next one, of course, we are assigning the image array of the right pointer using the one from the left pointer. Of course, we are not going to use the left pointer, instead we are using the temporary value. And so let's don't forget to left plus plus move the shift the left pointer by 1. Let's say if we have a sub array right like this, and we have the left pointer placed right here, and we move it by 1, and also for the right pointer from the one they place right here will be subtracted by 1 or shifted to the left. And if we don't do this, then of course we will get an indefinite or infinite iteration of the while loop right here. So let's run this to see what it is about. And of course we got the wrong answer, and the output it says 0 1 1, and it's flipped from the 1 1 0 right here, and for the next one is 1 0 1. Of course it is still the same reverse, and this 0 0 0 is still the same as 0 0 0. We off to a good start right here, and we successfully flipping it horizontally. And for the last one, we have to invert each element as the one that desired as the output answer right here. So to do that, we can use exclusive operator. Let's say if we have 1, and then in order to convert this to 0, and of course the opposite goes the same as 0 converted. If it's 0, convert it by 1, or 1 convert it to 0. To do that, we can use the exclusive OR operator in Java or JavaScript. I don't know if JavaScript can also do that, but in Java we can use the chevron sign with the equals sign right here and the 1 right here. So if we have the 1, using the exclusive OR right here will result in 0. Let's say if we have the 0 using the exclusive OR with 1, and the result will be 1. And another way, we can simply use the 1 subtracted by the one that we need to convert. Let's say if we already have 0, then we will get 1 right here if we want to flip the 0 as 1. Or let's say if we have, let me flip this to minimize the confusion. Let's say if we want to change the number, let's say the number is 0. Of course we are going to use the 1 subtracted by the number itself. If it's, let's say if we have a number of 0, then is equals to 1 subtracted by 0, then the answer will be 1, and the resulting will be 1 right here. And the same thing goes if we have 1 and we want to convert 1 to 0, like the exclusive OR operator, then we can simply use 1 subtracted by 1. We can use 1 subtract prefix right here to fulfill our needs, or to invert the each of the element of the sub array right here. So to do that, we can simply use for the temporary value, we can use the 1 right here as the 1 operation. Aside by flipping, we also inverted the elements of the sub array like as we desired. So let's run this again, and this is the output, and this is the expected one. The output, it says 1 1 0 and 0 0 0 and 1 0 1. If you notice something, the 1 right here is not being converted properly. It's because the while loop right here, left is, as long as left is below the right, then if we have odd numbers of the subarray, we have the length of 3, then of course we are going to operate the first element. Let's say if we have 1, 1 and 0, then of course we are going to convert the 1 and 0 on the first and the last one. Then it will convert 0, 1 and 1 without any regards of the middle elements right here. And it does differently on the length subarray of 4. Let's say if we have 4, 1, 1, 0 and 0, then of course if we happen to flip it horizontally, the while loop right here will also affect the middle part 1 and 0 right here. Flipping it horizontally will result in 0, 0, 1, 1, and inverted will result in 1, 1, 0 and then 0 again. And for the 4 elements, this will affect since it's an even elements but not on the odd elements. To get around this, we can simply use an if check to check if the image array, check if it's odd. We are using the modulo of 2 is not equals to 0. In other words, the image array, I forgot to use the length property. In other words, if the array is odd or dividing by 2 is not equals to 0, or by the modulo, 3 modulo by 2 will have a remains of 1, since 2 multiplied by 1 is equals to 2, and then 3 subtracted by 2 will equals to 1. And of course, let's say, in other words, 3 divided by 2 is equals to 1.5, and 1.5 right here, 1.5 is equals as the remains of 1, and 1 is not since 1 is not equals to 0, then of course we got the odd elements of the sub array of the image array right here. If it's an odd array, then we can simply use the image array and we can get the image array dot length. I'm using the square brackets right here, divided by 2, and of course we can get the middle part of the image array right here. So you might be asking, why am I using the image array and then using the square brackets right here, using the another image array dot length property of length divided by 2, and that way we get the middle part of the array without even counting it by 1. So it's always returning the middle part of the array. And then to assign this, since we cannot use the 1 and then using another image array dot length, of course we can use the exclusive OR operator of 1 right here. So let's run this to see if it works. And let's submit this. And we have the runtime of 100 milliseconds. Okay, so let's run this again, retry this to see if it works. Okay, so we have the runtime of 0 millisecond as expected, and the memory complexity of the 44 megabytes is because we utilized the 2 pointers right here, and we're storing the temporary, and we have the operation of the modulo and the length divided by 2, and with the exclusive operator using the 1 right here to flip the value between 0 and 1 respectively. And so that's about it. I hope you understand this explanation, or if you have any questions regarding this challenge, you can ask me in the comment section. I will happily answer it. And also, if you have any better solutions regarding this one, if you want to point out something that I made a mistake on some parts, you can also tell us what you think in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.